back to eCoreAcademy, everybody. As you can see, I have a new Algebra 2 lesson prepared for all of you. My name is Anita and I am one of the teachers and co-founders here, along with my younger brother, AJ Raj. Today, I'm bringing to you a new lesson, so let's check it out. We're going to be continuing Algebra 2, Quadratics unit by doing the solving quadratic equations lesson. So in the last two lessons, I refreshed your memory of how to factor quadratic expressions. In the first of those two videos, I showed you how to factor them, as in just the basics that you probably learned from Algebra 1, hopefully learned from Algebra 1, but we just jogged your memory with those. And then in the last video, which was part 2, we went over different kinds of scenarios, as in perfect square trinomials and difference of squares. So you might have seen those kinds of scenarios before, but we just put a name to that scenario, so it's easier for you to identify when you're solving these problems. So you're pretty much looking at quadratics from the lenses of a higher level math student in this course. So now we're going to be taking it to the next step. We're going to be factoring quadratic equations, but now let's see how we can use factoring to solve quadratic equations when they're equal to 0. So you're going to have that same quadratic equation in the form of ax squared plus bx plus c, but now we're going to have it become an equation, not just an expression. It's going to have an equal sign, and we're going to try to make it equal to 0 so we can solve for x. So let's get right into the video. Before I show you the first slide of notes, I would really appreciate it if you pause and like the video. Also subscribe to the channel so you can join our ever-expanding community of students. Additionally, please comment down below, hit the post notification button, and share using our socials. So do all of that, please, and then we'll get right into the video. So here are some quick notes that I would like you to take into consideration. I really just want to go over how we would do this. Solving quadratic equations are pretty much the exact same thing as factoring quadratic expressions, except now we're taking it to the next level where we're going to be solving for x. So let me show you exactly what that means. So notice how we call quadratics equations, not expressions now. So what does this mean? So when we call them expressions, as you know, expression is when you don't have an equal sign. So you'll have some kind of algebraic, algebra written out, and typically you all are used to something plus something, usually a variable is thrown in there, equals something else, or something minus something equals something else. You're used to seeing that equal sign, and then you're used to solving for the variable. With expressions, you all know we worked with quadratic expressions. They came in this form. Ax squared plus bx plus c. Notice how there's no equal sign. Expressions don't have equal signs. Now we'll be calling them quadratic equations because if you look down here into this little green box, I have that same thing, ax squared plus bx plus c, but notice how now it's equal to 0. So to solve these quadratic equations, we're trying to take the expression and set it equal to 0. So when we factor, we'll have typically two sets of parentheses, x plus or minus some number plus times x plus or minus some number that is equal to 0, so that we can find usually the two different solutions of x. And if you're confused by that right now, don't worry, I'll be explaining it as we go through this slide. So now I want you to understand what the zero product property is. So what exactly is the zero product property? So the product can be 0 if at least one of the factors is also 0. So what does that mean? So the product can be 0 if at least one of the factors is also 0. So let's break that down. So if I told you x times y is equal to 0. So we know that whatever we know x and y are the factors and 0 is the product. Applying the zero product property, we can then say that at least x or y has to be equal to 0. Because if we think about it, one of these because 0 times any number is equal to 0. Therefore, if x is equal to 0, then y can be any number including 0, and we'll still get 0, so that satisfies this equation. If y is equal to 0, x can be any number including 0, and that will also satisfy this equation. Therefore, one of those factors has to be equal to 0. That's what the zero product property is trying to say. Therefore, if we wrote it in terms of like algebra, if a times b equals 0, so just like x times y equals 0, then a has to be equal to 0 or b has to be equal to 0. So in this case, x has to be equal to 0 or b has to be equal to 0. So that's what it's trying to say. And as we go through these examples, you'll understand what I mean. So when we factor this ax squared plus bx plus c, like I said, we get something that looks like this. We get x plus or minus some number times the quantity, this is typically what we get, x plus or minus some number equals 0. So how do we apply the zero product property to that? So think of that set of parentheses, that first set of parentheses and that second set of parentheses. Think of each of these as factors. So think of this set of parentheses as one factor, and then think of this set of parentheses as another factor. And then 0 is your product. Therefore, if we're applying the zero product property, at least one of these set of parentheses has to be equal to 0. Therefore, x plus or minus some number has to be equal to 0. And if we get that equal to 0, one of the set of parentheses is 0, so 0 times the other set of parentheses is going to give you 0, which satisfies that equation. And as you can see, because there are two sets of parentheses, you usually have x plus or minus some number times x plus or minus a different number. So each set of parentheses usually has x plus or minus a different number. Therefore, you usually end up with two different solutions. And like I said, as we go through these examples, it'll be easier for me to explain exactly how you can get there. Sometimes you'll have only one solution. We'll be going through an example where that's the case. And in other cases, you'll have no solutions at all. We don't have any examples with those, but as we go through this quadratics unit, you'll see where that comes into play, where you don't have any solutions at all. And lastly, I just want you all to know that when I say solutions, you can also refer to them as roots, zeros, and x-intercepts. They all mean the same thing. So in class, you might hear your teacher say roots, zeros, and x-intercepts. Like I just said, they all mean the same thing. So roots are, because we have an x squared term in here, you're square rooting it. So we call the solutions roots sometimes. We call them zeros as well because you're setting the equation equal to 0. Typically, you see standard form as y equals ax squared plus bx plus c. In this case, you're seeing 0 is equal to ax squared plus bx plus c. So that y term is substituted with a 0. So that's why we call it a 0. And you might also see x-intercepts. When we get into graphing, you'll understand what this means. But x-intercepts, just like a y-intercept, is where your graph crosses the y-axis, and x-intercept is where your graph crosses the x-axis. And those will be, that's when y is equal to 0, and thus they're also your solutions. So they all mean the same thing. Just know that we are solving quadratic equations. No longer are we just factoring expressions. We're going to factor them, take them to the next level so we can find out what x is equal to when your quadratic equation is equal to 0. So let's go to the first example. So here's a very basic example. Here's the problem. So find all possible values for x if the quantity x plus 1 times the quantity x minus 2 is equal to 0. So this is the problem. Let's get right into the solution. So I want you all to notice how this has already been factored for you, but it will not be the case from now on. So if you look at this equation right up here, you see that's already been factored. We've already divided the quadratic expression that was on the left side of the equation into two different parentheses. These would be its factors. So typically you would be given a quadratic expression, and then it'd be an equation because you would set it equal to 0, and then you'd have to break that down. Your quadratic would be in the form of ax squared plus bx plus c. But notice how this has already been factored for you. So it's already been factored for you. Now you just need to solve for x. And I'll show you exactly how to do that. And remember, keep the zero product property in mind. If a times b is equal to 0, then either a has to equal 0 or b has to equal 0. So either the first set of parentheses has to equal 0 or the second set of parentheses has to equal 0. Therefore, there are two possible solutions. There are two possible values of x that can satisfy this equation. So I just want to show you all the solution and the workout before I actually go through it with you, because I know a lot of you like to copy it down before I actually go through it. As I go through it, I'll rewrite all of this on the screen and I'll explain it as I go through it, as I always do in my videos. So if you want to take a second to pause the video and copy this down, totally feel free to do so. I'll be moving on and I'll be rewriting this and explaining it as I go. So hopefully that was enough time for you to copy that down if you wanted to. So now let's get into how exactly we're going to solve this. So I'm just going to rewrite this this equation that we have up here, already factored, x plus 1 times x minus 2 equals 0. So we're going to be figuring out what x is. I'm going to already tell you that there are two solutions for x that satisfy this, because remember, this is our first factor. Think of this as a. And this is our second factor. Think of this as b. A times b is equal to 0. Therefore, this can equal 0 or this can equal 0. And think of these as their own separate little equations that you're multiplying together, and you have to get 0 at the end. So I can show you exactly how to do that. So like I said, think of these as two separate equations. So think of this x plus 1 as its own separate equation. If you're thinking, Anita, how is this an equation? Right now it's just an expression because we don't have a equal sign. Well, think of x plus 1 as equal to 0. Because remember, we're trying to solve for x here. So, and we know that this is equal to 0. So we need to find what value of x plus 1 is equal to 0 so that this set of parentheses times this set of parentheses is equal to 0. So that's what you're going to do. You're going to take your first parentheses, take that expression, and set that equal to 0. Next, you want to just do simple algebra, and you want to subtract 1 from both sides, and you get x is equal to 1. If you plug this back in, negative 1 plus 1 is equal to 0. And if you put negative 1 into this equation, negative 1 minus 2 is negative 3. Because the set of parentheses, this first one is already equal to 0, 0 times negative 3 equals 0. So you don't need to worry about the second set of parentheses. Now, however, there is a second solution. So if you decided to go with the second set of parentheses, you see this is the case. So I'm going to write this x minus 2, that expression in the parentheses down here. I'm going to set that equal to 0 because, again, we're making an equation now. And doing simple algebra, we add 2 to both sides to get x by itself, and we get x is equal to 2. So if we plug 2 back in for x, 2 plus 1 is equal to 3, and 2 minus 2 in the second parentheses is equal to 0. 3 times 0 is equal to 0. Therefore, 2 also satisfies this. So these both satisfy this equation. Therefore, we can write that x is equal to negative 1 or 2. And you might be confused. You might be like, why are there two solutions? You might understand how I got there, but you might be wondering, how with quadratics are there two solutions? In part, it comes to the fact that quadratics include x squared terms. Therefore, if you think of the squared, that 2 and the exponent as two solutions, just think of that as the way we got two solutions in this case right now. Again, that's not going to be always the case. When we get into more graphing and looking at the x-axis and x-intercepts, you'll understand that better. But just know that we tend to get two solutions because of that x squared term. Okay, so now let's go on to the next slide. Here, let's do an actual problem. This is problem number 1. And I want you to solve the following quadratic equation for x using factoring. So the quadratic equation is 2x squared plus 4x equals 6. And you might be thinking, this looks nothing like what we've been doing so far. Why did you just throw this at me? Well, we're going to be solving this together. And if I break it down, hopefully it'll be easier for you to understand. So here's the solution. Like I said, I already pre-write it for you. So if you want to take a second to pause the video and copy that down, please feel free to do so, and then I'll continue afterwards. Okay, hopefully that was enough time. So now let me just clear this off the screen so that we can continue on, and I can write the solution for you, and I can explain it as we go. Okay, so I'm going to rewrite this equation right here. So we have 2x squared plus 4x equals 6. I want you all to notice how we have an x squared term, which is our quadratic term. We have an x term, which is our linear term. But where is our c? Where is our constant? We don't have a constant. And also, this is not set equal to 0. This is set equal to 6. In order for this to work properly, in order for us to properly find what x is equal to, we need to have our equation set equal to 0. Even if we're missing an ax squared or a bx or a c, we need this to be equal to 0 at the end of the day. Therefore, to get this equal to 0, think about what we should do. So in order to get this equal to 0, we need to get rid of the 6 on the right-hand side of the equation. Well, to get rid of a positive 6, you can just subtract 6. Therefore, if we subtract 6 from both sides, we get a 0 on the right-hand side of the equation, which is what we want. So if we subtract 6 from both sides, we get 2x squared plus 4x minus 6 equals 0, which is what we want. So now you can see we've gotten that c, which is our constant. So now we're good to go. It's in the form ax squared plus bx plus c. equals 0. So the next step we want to do is now we actually have to factor this. Remember in the last problem is already factored for you. Now we actually have to factor this. So the first step of factoring is seeing if we can GCF something out, especially because the absolute value of our A term is not equal to 1. Our A term is equal to 2. So is there any possible way that we can factor 2 out? Well, yes, there is, because 2 goes into 4 and 2 also goes into 6. So we can factor 2 out. So if I pull 2 out, I can rewrite this as 2 times 2x squared divided by 2 is x squared, which is what we wanted. 4x divided by 2 is just 2x, and negative 6 divided by 2 is 3. So this would be minus 3, and that is equal to 0. So we just factor that out. We just GCF that out. Now we're just gonna factor this like a normal quadratic. So let's look at our C term and let's break it down into its factors. So because 3 is a prime number, its factors are 1 and 3. So how can I add or subtract 1 and 3 to get 2x? Well, to do that, I can do 3 minus 1 is equal to 2, and that is our B term. So this works. So if we have positive 3 and negative 2, positive 3 and negative 1, we get 3 minus 1 is equal to 2, and 3 times negative 1 is equal to negative 3, so this will work. Therefore, we can rewrite this factors. So we can rewrite this quadratic expression as its factors. So we can do 2 times x minus 1, we can decide to put the negative 1 in this first set of parentheses, and then times x plus 3. So we just factored that, and that is equal to 0. So we just solved that. Now what we want to do is we want to take this the expression in the first set of parentheses, and we want to set it equal to 0 like we did in the last problem. So x minus 1 is equal to 0. To get x by itself, let's add 1 to both sides. So x is equal to 1. And let's do the same thing with the second set of parentheses. So x plus 3 is equal to 0. And if we subtract 3 from both sides, we get x is equal to negative 3. Therefore, we have two solutions to this problem. X can be equal to either 1 or negative 3. And that is how we solve that. So in this case, I just want to recap why this was a special problem. First, we had to subtract 6 from both sides to get the right side of the equation equal to 0, and so that we can get a C, so we could get a C term. Then we could GCF 2 out, and we simplified it so that A was equal to 1, and then we just went about factoring it normally, and then we found the two solutions, which were 1 and negative 3. If you want to, you can take a pause and plug 1 and negative 3 back into the 2 times x minus 1 times x plus 3 equals 0. You'll see they both work, and they both have the left-hand side of the equation equal to 0, and the right-hand side of the equation also equal to 0. Okay, let's go to problem 2, which is going to be another scenario. So this is going to be a little bit special in that I'm just going to tell you right now it's going to have one solution. And when we go through this problem, hopefully you can apply skills that you learned from the last video about those special kinds of factoring situations, and you'll be able to identify what this is. So I just want you to take a second, look at this quadratic equation that I have up on the screen. X squared minus 12x plus 36 equals 0. So I want you to take a second to look at that. See if you recognize any of its properties. Is there anything special about it? Just think about it for 1 second, and then I will tell you. Okay, hopefully that was enough time for you to either pause the video or just come up with an answer. Notice that this is a perfect square trinomial, and these have only one solution. So remember, your perfect square trinomials are in the form of a squared plus 2ab plus b squared equals let me just write it up here. So you have perfect square trinomials. You have two kinds of perfect square trinomials. You have some that look like this: a squared plus 2ab plus b squared is equal to a plus b, and that's squared. So if this factor is squared, it's just a plus b times a plus b. You also have some that look like this: a squared minus 2ab plus b squared is equal to a minus b squared. So those are the two perfect square trinomials you have. As you can see, because there's a negative sign right here, this is what we're going to be using. So hopefully you notice that this is a perfect square trinomial, and I just want to give you a heads up right now that these only have one solution. And as we factor this, I'll show you how that works and why that is. So here's the solution already pre-written. If you want, please take a second to copy that down, and I'll continue on. Okay, hopefully that was enough time for you to pause. So now let's solve this together. I'm going to rewrite this down here. So x squared minus 12x plus 36 is equal to 0. So let's see, can we GCF anything out? No, we can't GCF anything out. So let's get right into factoring this. Let's just get right into breaking this down into a minus b and that quantity squared. So let's look at 36's factors. What if we square root 36, what do we get? We get 6. So we have to somehow find a way to manipulate 6 and 6, because remember, this is a perfect square trinomial. We square root the c term, so we get 6 and 6. How can we add, subtract? What can we do with 6 and 6 to get negative 12? Well, we can subtract negative 6 from negative 6. So if we do negative 6 minus 6, we get negative 12. And we get negative 12, and negative 6 times negative 6 is equal to 36. So that works. So then we can just put these into two sets of parentheses and rewrite this. Perfect square trinomial is x minus 6 times x minus 6 is equal to 0. Also, you probably know this already, but you can rewrite this as x minus 6 and that quantity squared equals 0, because it's just two sets of parentheses with x minus 6. However, for the purpose of solving this, I wrote it out like fully expanded so I can show you exactly why we're only going to get one solution. So let's go about solving this as we normally would. So let's take the first set of parentheses. Let's take that first expression, so x minus 6, and let's set that equal to 0. If we add 6 to both sides, we get x is equal to 6. Okay, so now let's do the second set of parentheses. So we have x minus 6, which is the exact same expression from the first set of parentheses. If we add 6 to both sides, we get x is equal to 6. As you can see, in both cases, x is equal to 6. So are you going to end up writing x is equal to 6 and x is equal to 6? Well, no, because that just doesn't make sense. So you have only one answer here. It's just x is equal to 6. You're not going to be redundant and write x is equal to 6 or x is equal to 6. You're going to write x is equal to 6 once. So in this case, perfect square trinomials, you have one solution. This case, it would be 6. If you plug 6 back in, you'll see that it works for solving this and satisfying this equation. So the left side of the equation is equal to 0, and the right side of the equation is also equal to 0. So now let's go to our last kind of problem. I don't want to say this problem is funky looking, but it's probably something that you totally weren't expecting because it doesn't have a lot of the traditional parts of a normal quadratic equation. So we have solved the following quadratic equation for x using factoring. So we have 10x squared equals 5x. So that might look a little bit bizarre, but again, remember, algebra is all about manipulating equations, so we get them to do what we want. So here's the solution already pre-written for you. There are two solutions to this, and this is a little bit special, and I'll show you exactly how that is special. So if you want to copy this down, please take a second to do so. Okay, hopefully that was enough time, so now let me get into doing this solution with you. So let's rewrite this quadratic equation right here, 10x squared equals 5x. So, like I said before, we want the right side of our equation to be equal to 0. That's the only way we can solve for x in the simplest manner possible. So, in order to get the right side of the equation equal to 0, we need to subtract 5x from both sides, because positive 5x minus 5x is equal to 0. So, let's subtract 5x from both sides. If we do that, we get 10x squared minus 5x is equal to 0. As you can see, we have an x squared term, which is our quadratic term. We have an x term, which is our linear term, but we don't have a constant. We don't have that c value, which is totally fine. We can still solve this without that c value. So how would we solve this? Well, let's just go about factoring as we normally would. First, we need to see if we can GCF something out, especially because our a value is not equal to 1. Our a value is equal to 10. Well, can we GCF something out? If you look closely here, you can actually GCF 5 out because 10 divided by 5 is 2 and 5 divided by 5 is 1. 2 and 1 are both prime numbers, so 5 is the GCF, which is the greatest common factor of this set, which is 10 and 5. Also, you can factor an x term out because if you divide x squared by x, you get x. You can also divide this term over here, 5x, by x, and you'll get just 5. Therefore, together, we can factor out 5x, and I'll show you exactly how. So if we factor 5x out, if we call this our GCF, we get 10x squared divided by 5x is 2x, because 5 times 2 is 10, x times x is x squared, and negative 5x divided by 5x is just negative 1, because 5x divided by 5x is just 1, and because there's a negative sign, it's negative 1. And this would be equal to 0. So you can see that if we have an x squared term and we have an x term, you can always factor the x out. And you should also look for a greatest common factor, which is a constant, when you look at your a value and your b value. So just applying those basic skills of simplification and factoring and pulling things out, we simplified this to 5. We expanded this, to 5x times 2x minus 1 equals 0. Now you might be wondering, how do we find the two values of x? Well, now you have to think of this 5x as the first set of parentheses, and you might be thinking, why is that? Well, it has an x term, so you need to think of this as its own expression. Let me show you exactly what I mean. You can set this 5x equal to 0 because, like I said, it has an x. So 5x is equal to 0. If you divide both sides by 5, 0 divided by any number is equal to 0. So you find that x is equal to 0. So if you ever see something like this, if you are able to GCF an x term out of your quadratic equation, and you get something like 5x or negative 2x or something like that, your x is going to be equal to 0 because you're going to be ending up setting this this expression in the first set of parentheses equal to 0. You'll divide both sides by whatever the coefficient is, and you'll get x is equal to 0. So in this case, x is equal to 0 does satisfy this, because if we plugged it in, 5 times 0 is equal to 0 in this first set of parentheses. 2 times 0 is equal to 0, minus 1 is negative 1, but 0 times negative 1 is equal to 0. So that works. So let's do the exact same thing with the second set of parentheses. This might look a little bit more normal to all of you because this is what we've been doing so far. So let's get this 2x by itself. Let's add 1 to both sides. And then let's divide both sides by 2 to get x by itself. 1 divided by 2 is 1/2, or 0.5. I'm just going to write 1/2. Therefore, both of these are the solutions to this. So if x was equal to 0, it would satisfy this. And if x is equal to 1/2, it would also satisfy this. If you want, you can plug 1/2 in, but you'll see that it does satisfy this. So that is how we solve this. Again, the two solutions are 0 and 1/2. So that's all I have for you today. I hope you enjoyed the video. Just a quick recap. We went over solving quadratic equations. So after factoring these quadratic equations, we set them equal to 0, and we found out what x could be equal to satisfy that equation. So we went over some scenarios like where we're GCFing, where we have a perfect square trinomial, and where we don't even have a c term. And in all cases you saw, we were able to successfully solve so we can find out what x was equal to satisfy that quadratic equation. That's all I have for you today. I hope you enjoyed the video. Please like and subscribe if you did, and also hit the post notification button so you're notified of our latest posts. Please also drop a comment down below so we know what you think. We love to hear your advice and other comments so we can tailor our content accordingly. Lastly, if you have any personal or business correspondences, please email us at our Gmail, which is eCoreAcademy@gmail.com. Please also look out for our social media posts on Facebook, Twitter, and Instagram. We're going to be launching our website soon, so please look out for that. It has a bunch of sweet functionalities for you students, including all of these videos organized into nice courses for you. So if you're taking a course in school, it's easier for you to follow along. We also have notes and self-assessment quizzes and a bunch of other stuff that you should totally check out. Okay, I'll see you in my next Algebra 2 video. Please look out for more quadratics, and I hope that was helpful. See you next time.